Welcome to lesson 6.3% of a quantity. This is one of our first experiences working with is over of equals percent over 100, the percent proportion that we've learned in class. So I'm just going to remind you here, is over of equals percent over 100. And it might be important to remember and note, like we took notes on in our flip book recently, that the is always talking about the part, or the of is always referring to the whole or the total. Just like the percent here is talking about a portion of the total 100%. Okay, we're going to use this setup to kind of get us going. I have only assigned evens in my class, and if I reference the date, it is currently November 8th, 2018. So if you're watching this at a different time, a different year, the directions may be mildly different. But for my class, 2018, we are looking at doing just evens. I do want to take a look at number one. I purposely did not assign this. It is not an even number, but my students every year would look at this and kind of panic. Here you're actually given a bar model, so there's a useful tool kind of sitting in front of us to kind of help us see this is over of equals percent over 100 or percent proportion method. Number one, what is 45% of 36 feet? Well, I like that in this bar model, they took the entire bar, the whole length of it, and they call that 100%. And you notice that they say of 36 feet. They're really talking about of the whole or the total. So they also label this 36 feet as the same as or equivalent to 100%. So this is getting a quantity measurement and also a percent measurement. When you move into the harder problems in this lesson, you may want to use this bar model approach. It may be helpful to understand kind of the way that they set this up. If you look, it also shows me that 45% is just a piece of, it's just a part. But notice it's a percentage, so we need a quantity to go with it. So we don't know how many feet are equivalent to 45% yet, but we're going to find that out. So they've set this up really nicely for you. So again, you can see the totals or the whole is referred to in this top bar or bracket, and the parts are set equal to each other in the bottom portion here. Well, let's go ahead and try percent proportion, just because, again, I think this is useful. This is another example for your notes if you need another one to jot down and just try with me, or if you just want to try it on your actual assignment, even though it's not an assigned problem, it might be a good idea to practice. So the number that we're always consistent with, the number that will always appear in your percent proportion is 100, and it's always in this bottom right. So for our purposes, we always set it up in the denominator of the second fraction. Well, if you dig back in here, 100% is the same as 36 feet. So the percents are always going on the right, and my quantities are always going on the left, my number values. So this 36 goes with the 100%. They're both representing the total. They both go in the denominator. Well, I'll move to the next portion of my bar model. Sometimes it's easier to find it in a bar model than just in the words. And I know that 45% is mentioned. Well, that is a percentage, and it's 45% out of 100 total percent. So percent always goes in the numerator of the second fraction. With this next piece, I notice that there's a question mark here. We don't know how many feet belong with this smaller piece of the bar. So that's the unknown, and here I would encourage you to use a variable. We've been using x today. I think that's a good move. Okay? If you look at your directions, it says, step one, carefully set up the proportion. That's what we've done. Step two in the directions that we took in our flip book would tell you to look left. So we're going to look to the left side of this proportion. Is there anything we can simplify? No. So then we would look right, and actually there are some things we can simplify here. 45 and 100 both divide by a common factor of 5. So let's do that. Let's simplify a little bit. So we always look left and we look right before we cross the street. Okay, there's a song that says, first use your eyes and ears, then we use our feet. So let's start here. 5 goes into 45 9 times, and 5 goes into 100 20 times. I really might want to do a rewrite step here. So I have not simplified my original fraction of x over 36, but I do have a simplest form of the fraction on the right. It says 9 over 20. There's nothing more to be simplified in this process, so I'm instead going to move to step 3, cross products. Remember, when we cross multiply here, we're moving diagonally, and we're going to set our cross products equal to each other. So 20 times x is actually 20x. And 9 times 36, I can probably do some mental math if I'm careful. 9 times 30 is 270, and 9 times 6 is 54 more. So I have 270 and 54 more. Hopefully you're recognizing that's going to give us 324. Well, I've shown you today how to solve one-step equations, something that you should have seen in the elementary. I hope that's the case. So we want to isolate this variable, get the x alone. If you recognize that multiplication is secretly happening here, we're going to use the inverse or the opposite. Instead of multiplying, we need to divide. I'm dividing by 20 on the left, so I need to do the same thing on the right. We keep balance in our equations. So I need to figure out how many times 20 goes into 324. I can see I didn't plan for space very well, so I'm moving this direction. Hopefully you're working on lines and have a little more room than I do. 20 does not go into 3, but it goes into 32 once. When you subtract, you're left with 12, and bringing down the next place value, we'll treat that as it's 124, and that does divide by 20. It goes in there 6 times. 6 times 20 is 120. When I subtract, I'm left with 4. You have a couple of options here. It looks as if a decimal option might be a possibility because I know 20 is pretty friendly. So we could move to a decimal solution. I also could stop right here and just write this as a mixed number. That would be acceptable. So maybe I'll show that first. We could say x equals 16, because that's my whole number, and 4 20ths. Hopefully you'd say, well, wait a minute, I noticed something. That's not in simplest form. So we would instead simplify and get x equals 16 and 1/5. This is not a final answer. We need to give these labels. We've been measuring these quantities in feet, so I should make sure that it indicates feet at the back. Bam. Okay. This is one possibility. Now others out there are going to say, no, I'd rather go to a decimal with this. So if that's the case, you would put a decimal point behind the whole number 324 and show one place value behind. This is getting us to the tenths place. And this decimal would also move straight into your quotient. We have to be careful with our alignment in decimals. And I'm ready to divide. I bring down the next place value and I treat this as if I have 40. 40 divided by 20 is 2. 2 times 20 is actually 40, and when I subtract, there's nothing remaining. So another form of this great answer would be 16 and 2/10 feet. 16 and 2/10 feet. I want to see if this makes sense. 100% compared to 45%. Well, 45 is almost half. It's almost like 50%. So 36 split in half is 18. So I need a number slightly smaller than 18, and it looks like for reasonability purposes, this checks out. I'm going to move on with some evens just because that's what was assigned, again, in 2018. Oops, and I'm going to have to slide our paper a little bit here. And I'm also going to have to find us some extra workspace. I thought I had enough on the last one. I proved myself wrong there. So for today's purposes, I want to make sure you have out your lined paper. You'll pretend that this is lined with me, I hope. So, number 2. I didn't read the directions, and I can see I covered them up. Find the quantity represented by each percent. So there's an unknown quantity. For number 2, I'm just going to sketch out a bar model. It is not required for the assignment in 2018, but it is something that I think will help you when you get to those word problems. We saw that today in class a bit. So if I were to draw a bar model instantly, the whole bar always represents 100%. And now I'm ready to dig into the problem and see if there's some more information to help me label. Number 2, 35%. Oh, there's a percent, and it's smaller than 100%. So I'm going to grab a smaller portion of my bar model and label it 35%. Then it goes on to say of 125 miles. Oh, there's that of. They're talking about of the total. So 100% is the same as 125 miles. Well, what I don't know then, if I have a percent and a quantity on the top, I'm missing something on the bottom. I have a percent, but I'm missing the quantity. I'm looking for some number of miles. I think I can find that. I can use my percent proportion every time. I did indicate to my students that I'm a dinosaur, I went to school with dinosaurs, and that maybe someone's going to try to persuade them to try this in another way. And I'm not opposed. There are definitely other strategies. The problem with some strategies is that they only work for certain types of problems. Like here, I could turn 35% into a decimal, 35 hundredths, and then just multiply times 125. Will it get me directly there? Yes, it will. But when you get down here, it gets a little more difficult when I'm missing other pieces of my proportion or of the problem. So I'm going to go with this is over of equals percent over 100. And I'd like you to kind of stick with me to see if you can make this make sense also. This is also a great lead into solving one-step equations, which again, I'm told our students have seen at the elementary level, but I have not seen successfully in the classroom yet. So let's give this a try. The 100 is always in the bottom right of my second fraction, and I'm looking for any information that I can fill in from the problem. Well, this 100% belongs to 125 meters. The 125 is the total. I know that the whole or the totals belong in my denominators. This 35%, well, that's a percentage. It has to go on the top right. The second fraction gets that percent in the numerator. The unknown piece then seems to be the part or the quantity that belongs with the 35%. Notice that the parts are both listed together here in my bar model, and they're both listed together in the same level of my proportion. I'm really ready. My setup was quite careful, which again is step 1 in your flip book. Well, next I tell you to simplify a fraction, meaning look to the left. So over here, can we simplify x over 125? Not so much. Look to the right. Can I simplify this fraction? Yes, you can. These both divide by 5. Now, we did have some discussion today. Sometimes if I notice I'm going to get 100x with my cross products, I might leave that alone. But let's go ahead and just continue with our steps so that we get the practice with it. 5 goes into 35 7 times, and 5 goes into 100 20 times. Let's do a really speedy, fast rewrite. I still have x over 125, but that's the same as 7/20. Step 3 in your flip book would tell you to cross multiply. Now, I gave you a hint in class today. We talked about always trying to put the king or the variable first. So I'm always going to multiply wherever that variable is first. Well, 20 times x gets me 20 x's. Here, 125 times 7. Well, I'm thinking this through in my head. 7 times 100 is 700. 7 quarters. Well, 4 quarters is 100, and 3 more quarters is 75. Oh, I can quickly see I'm going to get 875. And if you don't believe me, you can test it out, but I hope I'm right. Okay? We need to get this variable alone. We need to isolate the x. So I oftentimes say, who's messing with the king? King x here. He doesn't like something that's bothering him. Currently we have 20 kings or 20 variables. Quite confusing if you live in a kingdom. So we're going to fix this. If multiplication is happening here, we use the opposite or the inverse. We're going to divide. If I divide by 20 on the left, I divide by 20 on the right. A common error I saw from my students is that once they're done with their original proportion, they still want to put that 100 over here. But that wouldn't be equitable, would it? That wouldn't be using the same rule on the left and the right of my proportion. So do be careful. I want to treat both sides of the equation the same. Well, 20/20 is the same as 1 whole x. Perfect. The king's almost alone. And here I want to figure out how many 20s go into this number. So again, I guess I didn't plan my space very wisely. I'll move this direction. Trying not to play Dr. Seuss with my math work too much. 20 doesn't go into 8, but it goes into 87 4 times. When I subtract, I'm left with 7, and I'll bring down the next place value. 20 does go into 75. It goes in there 3 times, and I know I'll get 60 as a product, and when I subtract, I'm left with 15. Again, I noticed that divisor of 20 is pretty friendly. I probably have a couple of options, but I like precision. I like exact, and I think we're in a good spot to do that. Especially if we're talking about miles. We can talk about miles with fraction forms or mixed numbers. So I'm going to write 43 and 15/20. And now hopefully you're there saying, hold up, not a final answer. What could we do to both of those numbers in my fraction? Simplify. I would get 43, and dividing these both by 5 on the top and the bottom of my fraction, simplifying, I'd get 3/4. So cleaning this up a little bit. We don't want the king to see his shadow. This is just a nice cleanup. X means the same thing as 1x is worth 43 3/4. Well, I want to plug that back in. This was a word problem of sorts. I'm measuring in miles. Let's pretend you love those decimals and you decided to go to decimal land. Would it have worked? Could you have put a decimal point and a couple zeros back here to see what would happen? Yep, with just a step or two you would have been there. Okay, so that's also a possibility. 43 and 75/100 miles will also be an okay answer. Make sure you have a label on there for me. I am not going to set up number 4 or number 6 because they work similarly. The only thing I will point out with number 6, I know some of you are not going to like this a whole lot. The percent that they give me is 120%, which really means when I go to set up my proportion in a minute, that percentage is still going to sit in the numerator, even though it looks improper. It's not a problem. Okay, so food for thought on number 6. I'm not going to solve any more for you. I gave you a big hint there. Let's move on to the next section where it says find the missing value. And this is where my students struggle every year. If they're working with someone who learned this like I did with the dinosaurs, that dinosaur method works really awesomely right here for 2, 4, and 6, right? You can always multiply a percent, change it to a decimal, times the total if we're given the whole. But here we're missing the whole of what it says. We're missing the total. So we're going to try to find the total or the whole that's missing. Well, we're not told to draw bar models. It wasn't required today, but I noticed that I had some students that said, oh my gosh, it helps me to see it. So even though we've been bucking the system and not enjoying bar models, maybe we'll give it a quick try. Well, real fast, I know the whole bar will always represent 100%. When I'm starting out, this is 100%. Now we just mentioned we're missing the total. We don't really see of the total. So this is where my mystery piece is, right? That's where actually I probably should put an X because that's what we've been using in 7th grade math today. So this is X, and it doesn't have a label. It's not miles, it's not feet, it's not chinchillas, I don't know. So I'm going to leave that alone. And I'm going to look at the other pieces. 18%, well, that's just a small portion of this bar. I'm going to grab a small chunk and label it 18%. And it says it is 99. So 18% is equal to 99. It's exactly how I'd read that. These are equivalent. I think we're ready for our percent proportion. If you remember, is over of equals percent over 100. So the 100, always my bottom right. Well, there's my 100, check. What goes with it? Oh, the unknown quantity. That's the total that goes in my first fraction, right? The unknown. The of goes in the denominator. Well, next I see I have 18%. So this 18% is a percentage. It's going to go in the top right of my fraction. And this 99, if I make sense of this, 99 is a part that belongs with 18%. These are aligned, aren't they? I think we're ready. We did a careful setup. So step 2 would say, look left, then look right before you cross the street. I wish I could remember that song from kindergarten. I feel like we learned that when I was little. Anyway, checking the fraction on the left. I noticed that there's nothing that I can simplify. There's not a variable in both of these terms. We're just going to leave this fraction alone. But if I look to the right, I could do something here. This 18 and this 100, well, they both divide by, they're both even, they divide by 2. What about 4? No, 4 doesn't go into 18. 9 goes into 18, but not into 100. Let's stick with the divide by 2. 2 goes into 18 9 times, and 2 goes into 100 50 times. I think I'm in simplest form, and now it's time for us to follow step 3, cross products. So I'm going to take this 9 times x in a minute. I'm going to take this 99 times 50 in a minute, and I'm going to set these equivalent to each other. Okay? So I always encourage my students to start with the variable first, because then we don't have to worry about the order when we're done. So 9 times x is the same as 9 groups of x, or just 9x. And going the other way here, I have 99 times 50. Well, I know 90 times 50 would get me 45 with a couple zeros behind it, 4,500, right? Next, I'd have just 9 times 50 would get me 450 more. So just trying to demonstrate for you my mental math real quick. Looks like I'm going to get 4,950. Awesome. I now have an equation. It's a one-step equation. I can solve this. Secretly, I hope you remember there's multiplication sitting between any coefficient. This 9 is called a coefficient, a number that precedes a variable. So to undo it, we do the opposite. The opposite of multiplying is dividing. This is also called inverse operations. Now be careful. If you show it on the left, you must show it on the right. This equal sign tells you that everything has to stay in balance. So we're going to give it a try. Well, I wonder if I can do this one with some mental math. I'm going to try. I know I'm going to get one awesome king, one awesome variable. 9/9 is the same as one whole. So one whole king, that's good. He's not severed. Okay. Does 9 go into 4? Not so much. Does it go into 49? Yes, it does. It goes in there 5 times. Well, because 9 times 5 is 45. When I'm left, I would have 4 to bring down and a 5 to bring to the next place value. 45 divided by 9 is 5. And I still have this 0 sitting at the back, don't I? So it looks to me like I'm going to get 550. Again, if you are not able to see that mental math style, please set it up. Please go ahead and show me the same great steps that I just tried to walk through with mental math. Looks like I get the same great answer. I do want to clean this up a little bit. Notice this king is seeing his shadow on Groundhog Day. I like to joke about that, but honestly, the variable can be written just as x. One king is the same as just x. And next to it, we are just going to write 550. Did I have a label? Did I have units for this one? The answer is no. So here's my answer for number 8. 550 was the total. We should probably check to see if this makes sense. If 550 is the same as 100%, well, I'm thinking about 18% being less than half of it. Well, 550, half of that would be 250 plus 25. 275 would be about halfway. 275. And I kind of want to divide that, divide it by 5 to figure out just a smaller portion of that. I'd get about 110. It seems like I'm getting really close to that 99. It seems like it's a reasonable answer to me. Great. We are ready to move on here. And I'm not going to set up the other number 10 and 12 for you because they follow the same rules. The thing I will point out for you is this strange number 12. They're pushing you again. They're asking you to think about when you go to set up your percent proportion, what would 125% look like? Well, it's 125% based on a 100% system. So that right fraction is going to look improper for a minute, and that's okay. This will also affect your bar model if you think about it. My bar model, I always want to represent 100%. But in honesty, this is going to represent a little bit more. This bar model might need a little bit of a stretch. So if you're thinking bar models today and showing your thinking, making it visible, then you're going to have to think about a little bit of an adjustment to your bar model here also. All right, let's move on to the next section, which actually I think takes us to our word problems. I can see I need to move my toolbar forth. Number 14. There are 325 children at a zoo. If 64% of the children are boys and the rest are girls, how many children at the zoo are girls? Well, you're not required to draw a bar model, but I'll be honest, drawing those bar models is not a bad idea. I had a student today mention that, and I think it definitely was a useful tool. I didn't require it because I had my students complaining, why do we need the bar models? This might be why. If you notice, I have a total. I know how many children there are. There's 325 of them. Check. And not only that, this is 100% of the children. That's all of them. Well, 64%, I know that's a little more than half, so I'm going to grab a little more than half of my bar and call that 64%. And if you read, that was my boys, so I'm going to label this boys. But here's the mystery. They go on and they ask you, how many children at the zoo are girls? This is the question. They really want to know about this part. Well, there are a couple things that we could do here. First of all, I need to figure out this percentage. And then in a second, I need to figure out how many girls that is. Well, we had similar problems to this on our quiz recently, where we were given an amount for boys. We had to figure out the amount for girls. We could do a quick subtraction to get us at least there. Oops. But you do want to be careful. I almost grabbed my quantity and tried to subtract a percent. Do those match? The answer is no. I need to start with my percent, 100%, and taking away the boys' percent, I would be left with the girls' percent. So maybe doing a little regroup here, you should find out that 36% are going to be my girls. Now that's not what they asked for. Keep in mind, they didn't ask me how or what percent are girls. They asked me how many children at the zoo are girls. So now we're ready for our percent proportion. This boy information, it was helpful, but I'm done with it, and I'm ready for my percent proportion. I'm going to set up my proportion with 2 fractions right now. And I know 100 always goes in the bottom right. Well, 36% is important. It comes from this bar model, and it's a percentage. It belongs in the top right. When you're looking at our proportion setup, top right gets the percent. This 325, well, is it the quantity or the percent? Oh, it's a quantity, and it's the total quantity, so it goes in the bottom here. Notice it's across from the 100, just like it's across from the 100 in my bar model. Well, the unknown piece then is how many girls this is. This is X girls. I don't know how many are girls yet, but I'm going to find out soon. Well, I think we're ready for step 2. Look left. Can I simplify? Nope. Look right. Can I simplify? The answer is yes. Both of these numbers divide by 2, yes. But they also divide by 4. Ooh, 4 sounds nice. Maybe I tried that. Let's divide both of these by 4 and see what we get. 4 goes into 36 9 times, and 4 goes into 125 times. It might be valuable to go ahead and rewrite this if you're worried about your neatness and your organization, but I think I'm able to safely grab the new numerator and the new denominator in my cross products. We're ready for step 3. Let's cross multiply, or multiply diagonally. You wrote in your notes in your flip book. Well, first I encourage you to start with this variable. 25 times x is the same as 25x. 9 times 325, I might actually stack that up somewhere here. Nine times 5 is 45. Keep the 5, regroup the 4. 9 times 2 is 18, plus 4 more makes 22. Keep the 2, regroup the 2. 9 times 3 is 27, plus 2 more, that's 29. 2,925. 2,925. I should point out that I haven't even gotten there yet, but I had some students on their quiz recently that had, I don't know, 0.37 boys or 1.59 girls. Scary. I don't want partial anything here. So I'm excited that I see this is 25 and it looks like it might divide into this number nicely. That's exactly what I want to do. So to undo what's happening between this variable, my king x, and its coefficient 25, I have to do the opposite of what's happening there. If multiplication is secretly here, I must divide by 25. The number I want to see go away is the number I will use for my division. If I do this to the left of my equation, I must do this to the right. We want to keep balance in the equation. All right. Well, 25 25ths is really the same as 1 whole. Someone might say that they'll simplify, right? Or that they cancel out. I'm going to be left with 1x. I'm going to bring down this drawbridge, my equal sign. I'm going to keep this king safe. And I'm going to say, how many times does 25 go into 29? Once, with 4 left over. We bring down that 2. I have 42 divided by 25. Looks like it might go in there once. So 42 take away 25. Looks like I might get 17. Well, next I bring down the next place value. 175 divided by 25. Well, I know that's 7. And if you don't believe me, go ahead and stack it up, because it's very possible that I did something wrong in my mental math style tonight. As I try to cruise through this for my students. I think I'm good. 4 quarters makes $1 or 100 cents. And I need 3 more for 75 more cents. So there's going to be a 7 here. And I think I'm good to go. I still get the same great answer. Now I do want to plug this in. I know that x is going to be cleaned up. I'm going to set this king just equal here, looking a little bit simpler. So this is a simplest form, or a final answer form of a variable. We just keep the x by itself. And I do have this 117 happening. But do remember, this is a word problem, so you want to get some words back. What were we trying to find? The number of girls. Oh, so this is girls. You should be working on line paper. You probably will need to take up quite a bit of room like I did. And you do want to transfer your answers back so that I can see a good answer. And then I can quickly go and find, well, number 14, your organized work here. 117 girls is a good answer. You might want to double check with reasonability, and you might even want to turn that into a Math and Focus awesome sentence. I'm good with that. But let's just think about whether or not this is reasonable. If I plug this 117 in here, I'm thinking 325 was the total number of kids or children. Half of that, well, half of 300 is 150. Half of 25 is 12.5. So 160 something. Am I a little under halfway? I am. I'm thinking that this looks pretty reasonable. So 36%, being the girls, should be a little less than half, and it looks like it is. I think this is a reasonable answer. I will try to get another couple set up for you, but I don't want to lead you too much into the work, because then I notice that sometimes my students don't rely enough on themselves. I have to apologize, I can't seem to drive this tonight. Are you allowed to do the odds because you feel like you need the extra practice? Of course. Uh-oh. Ziggy's not cooperating again. There we go. Number 16. Of the 1,640 students enrolled at a school, 50% come to school by bus, 35% come by car, and the rest of the students walk to school. How many students walk to school? Again, bar models were not required, but I think that it's worked well for us so far. So a really quick look at this, it helps you to organize where your quantities go, where your percents belong. The first sentence I read, a total number of students. That's how many students are enrolled. That sounds like the 100% to me. 100% is the same as 1,640 students. If I read on, it says 50% come to school by bus, 50% bus, so that's about halfway, isn't it? We'll grab about halfway and call that 50%, and I'm just going to write bus next to it for some good labeling. 35% come by car. Oh, 35% car. I can do this. So that's a little less than this 50%, isn't it? So I'm going to go with, somewhere in here, we'll pretend that this is my 35% by car. The last thing that it says is the rest of the students walk to school. How many students walk to school? So most popular wrong answer, students will just find me the percentage and call it a day. Well, yeah, there's a little bit of math to get there. But let's be honest, we need to turn that percent into a number of walking students. So I'm looking for the number of students who walk. Okay? I think you can see real quickly with this setup what you would need to do to figure out this percentage, this unknown percentage. So if I have 50% busers and 35% car riders, I could kind of take all of this away from the total, couldn't I? And whatever that remaining percent is would get me started with my percent proportion. So I think I'm going to leave it here with a bar model in mind. I'm going to remind you we're using this percent proportion where 100 is always in the bottom right. This percent that you're going to find here in a minute would definitely need to go in the percent position in the top right, or the numerator of my second fraction. And hopefully you'll recognize the other pieces where they belong. So 1640, is that a part or a whole? Well, it looks like those are the whole bar. And over here, this blank number of students, the unknown, which I'll call X students for right now, does that belong with the whole bar or just a part of it? Oh, just a part of it. So giving you some big hints here, hopefully getting you a successful setup. You should not get partial students when you're done. If that happens, like I did to some of you on your quiz, something's not going well. Okay, we're expecting to get a total number of students. Keep in mind if they ask for a number, a percent number, sometimes our percentages aren't whole numbers, but our number of students should be. Cats, dogs, students, please keep them whole. Let's go ahead here to number 18. I should get a driver's license for this thing. Here we go. Number 18, 28% of the amount in Keith's savings is $350. How much money does Keith have in his savings? Well, 28%. Oh, there's a percentage sitting right there. I notice that this must be my percent. And then it goes on to say, is $350. Oh, that sounds like it's the part, or the is of my setup. How much money does Keith have in his savings? How much money? Well, they're wondering how much he has altogether. So X is really for the total. I don't know if I should draw you a bar model here. I don't know if I should start anymore with the setup. I think you have enough information to get this one going. Okay? So again, I'm really just dissecting. I'm doing a reread, and I'm making sure that I label the parts. I have a percent, top right of my second fraction. I have the part, and I know that because it says is. So 28% is $350. Those go together. This is good. And then that means that they'll be on the same level of my percent proportion. And the last thing it says is how much money. We have to figure that out. Now someone out there is probably panicking. They're like, you only gave me 3 pieces. And there are 4 parts to each of these percent proportions. You are so right. So what am I missing? Oh, the number that's always in percent proportion. Hopefully you remember what that is and where it belongs. Looking at number 20, we looked at a problem kind of like this today in class. We actually started number 22 together as a group. If you're watching this in 2018, this is a true story. Okay? If you're watching this a different day of the year, I can't promise. So number 20. Of the 400 people at the school carnival, 95% are students and the rest are teachers. How many students are at the school carnival? Okay. So what I like about this one is that I can see 400 people sounds like the total. I can see that 95% seems to be a percent. Okay. 95% are students. This is really helpful because then they go on to ask me how many students. These kind of align, don't they? So we're in a good spot. Meaning I have the information I need to set this up. Well, if I were to do this, number 20 on my line paper, I can start percent proportion. I could even start a bar model, which I would absolutely love to see from more folks, but I hear that we kind of complain about those. So, I don't know. I'll give it a quick go. 400 people is the same as 100%. Please be careful. Don't tell me 400 equals 100. That would be a lie. But 400 could be the same as 100%. There's a quantity and a percent here. I like it. 95%, that's quite a few of these, so I'm going to go quite a ways on my bar model. These equal the students, right? But do I know how many students there are? The answer is no. I'm going to have to find this in a minute. X students. Okay. What number is always true in my percent proportion? The 100. Where is it always located? Bottom right. I hope maybe using this setup that you're ready to roll. Okay. So go ahead and see if you can answer part A. I am going to kind of sneak ahead here, see if we can find information on part B. It says, if 55 of the students at the school carnival are boys. Oh, that's interesting. If 55% of the students are boys, how many are girls? Well, this is a different question. I mean, I'm going to have to take what I just got from part A. So this is part A. I should have labeled that on my workspace, part A. Okay. I'm going to have to take the total number of students that I find, and that's going to become my 100%. I'm just going to be talking about the students next. So however many that was, and I didn't solve this for you, so I can't tell you for sure, that's going to be your 100% of students. And then you're going to have to show me how they broke that bar into chunks for boys and girls. So really trying to give you some hints here. I hate to walk you through too much of it because I feel like, again, sometimes you're a little too reliant on me. So we're going to take our answer from part A and plug it into part B, into our bar model. It's going to become the 100%, or the total number of students. And then I think I heard that there are 55%. Were those boys or girls? Well, we better label them if you find out if they're boys or girls. And then the unknown piece, well, might do a little subtraction, might have to set up another percent proportion. I think you're going to find me how many girls. And again, I covered up my problem, so I can't promise. Yep, I agree with all of that. Part C, how many teachers are at the school carnival? There are a couple things you could do here. So you could look back and notice what was the total number of people at the carnival altogether? 400 was my total or my whole. And in a minute, you're going to have a total number of students. Oh, you're going to have a number of students that we could take away from the 400 people that are attending the carnival. I think this might be as simple as a subtraction down here for part C. The last one we didn't get to finish in class, so I think we probably should look at. I probably will walk you all the way through it because I think that it is pretty challenging. Number 22. I have to clear some of my notes here. We are here. We did try to set this up earlier. I appreciate that I had a student immediately say, can't we draw a bar model? Of course you can. And this one probably has a good reason to. And I know that with a quick skim, if you see this word remaining, you have multiple steps, my friends. So let's give it a try. Number 22, a box contains 160 fruits. That sounds to me like a lot of fruit. It also sounds to me like a total or a whole. This is super helpful. Of the total number of fruits in the box, 30% are apples. Oh, that sounds important. 30% are apples. Could we stop and just start modeling this? Number 22, let's see if we can see what we've read so far. And I don't always do that, but I see that there are a lot of pieces flying at us here. So I wonder if we could take it in parts, if we would be more successful in our bar model. Well, 160 fruit is our total. That's the same as 100%. There are 30% apples. Well, that's about a third of the bar, so I'll try to grab about a third here. I'm going to label that 30% apples. And then be careful because it says 25% of the remaining. It's kind of like we're going to take this remaining piece and we're going to rewrite it. We're going to work with this remaining piece in just a minute because it's going to show me that 25% of those remaining, well, 25%, that's about 1/4. My class earlier was able to tell me that 25% would be like 1/4 of this. Okay, and notice that those are pairs. So I might even kind of shade this in and just say, okay, I got this. Okay, the question is, how many oranges are remaining? So they don't want the percent of the oranges. In a minute, I'll be able to figure out, well, 25% plus 75%, okay, would get me 100%. So in a minute, this will be 100% of the remaining fruit. And the 75% has to be my oranges. So I'm going to have to figure out how many oranges that is. All right, well, let's back up a little bit. My bar model here is a really nice start. But what I care about is this remaining piece. So if I had 100% and I used up 30% of it, what is 100%? Take away 30%. Also, you'd say that's 70%. So this 70% is really what I care about. I used the apples up, they were helpful, but goodbye apples, I don't need them now. But what I do need to do is figure out what 70% is the same as. How many pieces of fruit are in the 70% of the bar? So I could use a percent proportion right about now. Is over of equals percent over 100. Well, I have the 70%. I see the percent sign. I know it goes in the top right. But next I have this 160 fruit. Well, was that the part? Did that belong with 70%? Or did that belong with 100%? Well, actually, that was the total, wasn't it? Do you see how these are on the same level in my bar model? They're on the same level in my proportion as well. I realize that this is moving from the top to the bottom, but they're staying with each other, aren't they? So the unknown piece seems to be how many fruit, the part of the fruit that represented 70%. All right, my class earlier today said you can simplify this. You can divide both of these numbers by 10. Notice we look to the left, not much to do. We look to the right, oh, we could simplify. 10 goes into 70 7 times, and 10 goes into 100 10 times. That's step 2 from your flip book. Step 3 would tell you cross products, cross multiply. So make sure you're grabbing your new numerator and your new denominator when you do this. Here I have 10 times x is the same as 10x. And I have 160 times 7. Well, 7 times 10 is 70. 7 times 6 is 42 more. Looks like I'm going to get 112 with a 0 behind it. 1,120. I want to double check that in my head. Sorry. 70 plus 42. Yep, I feel good about that. And a 0 behind it. Okay? You can also stack those up. You can check it out. But I think this will work for us. Now notice, I am not setting up the percent proportion. That's already been done. These are cross products, and I'm ready to solve for the variable. Get the king alone. So solve for x using inverse operations. Your notes should say something along that line. Well, we have to undo the multiplication that's here. So the opposite of multiplication is division. I show that with a fraction bar. If I do that to the left, I do that to the right. And when I'm done, 10 tenths is the same as 1 whole x. And here, oops, sorry, 10 tenths is the same as 1 whole. And that variable is still here on that variable term. Okay? 10 goes into 1,120. It's going to make this decimal hot one time, if you remember. If you don't believe me, you can actually set up the long division. But we've been talking a lot about these mental math strategies, haven't we? So here I get 1x equals 112. What does that mean to me? Well, if I clean it up a little bit, take away the Groundhog Day shadow, that means that the unknown piece from the first bar model is 112. Well, that's right here. There are 112 fruits that were not apples. There's something different. Well, I'm going to take this 112 and I'm going to plug it in over here. I know that I have 100% with my new bar. And this new 100% is the 112 fruit I just found. This is representing the total of the remaining fruit. Well, if I take a look at this, we already talked about the 25% were pairs, right? So I kind of can cross that off, and I know 75% is what's remaining. You could do another percent proportion here pretty quickly. Now my class chose not to do that. They chose to take this 112 fruit and they divided it by 4 units because they were thinking of unit rate. That's an awesome strategy. It will save on percent proportion also. You won't have to set up a second one. But maybe you didn't see that. So maybe you say, okay, percent proportion, here we go again. 100 is always in the bottom right. And the percent that I care about is 75%, so that goes in the top right of my second fraction. Well, the 112 is the total fruit. So it goes up there at the top with 100%, so it also belongs here in the total or the whole or the denominator of my first fraction. And the unknown piece then is my numerator, the part. What part of the fruit, right, belongs with oranges? Well, if you remember, I tell you to look left, look right before you cross the street. I wish I could remember that song. Anyway, looking to the left, I noticed that there's nothing I can simplify, but on the right, these both divide by a common factor, the GCF of 25. 25 goes into 75 3 times, and 25 goes into 100 4 times. I'm ready for step 3 in your flip book. Step 3, every time tells you cross products, cross multiply. What it doesn't say is set those cross products equal to each other. So I want you to do that now. 4 times x is 4x. And 3 times 112 would be 336. I want to keep my variable terms separate from what's called constants, so I bring down this drawbridge, this equal sign. Well, there are 4 kings, and that could be really confusing in life. It'd be better to rule the kingdom with just one. So the way to undo 4 times x is to divide by 4. And if I do that to the left, I do that to the right. Well, these 4s will cancel out. I'll be left with one fabulous king. He's really happy because he's almost alone. But on the other side, I have to figure out how many 4s go into this. So let's give it a try. 336 divided by 4. 4 doesn't go into 3, but it goes into 33 8 times, because 4 times 8 is 32. When you subtract, there's 1 remaining, and the next place value brought down becomes 16. 16 divided by 4 is 4, because 4 times 4 is 16. 84. This goes in there nicely, which is nice because we're talking about fruit. We were talking about cats, dogs, and people earlier. Well, fruit, you probably don't want halves and quarters of your fruit either. What did we just find? Well, when we solved for x, when we solved for this unknown, we actually found that there are 84 oranges. Again, my class did this earlier by doing something along this line. They figured out how many times 4 goes into this number. Well, 4 goes into 125 times. 4 goes into 12 3 times. 25 plus 3 is 28. There's 28 in each of these. 28, 28, 28, 28. And then you could quickly take 28 times 3 units, to see how many oranges. You should get the same great answer. I feel like that might be the end of the assignment, at least of the evens that I had mentioned we were going to work on. There are some other good challenging questions in here, and they're all fair game for your test, which we're looking at next week. So if you're talking to me or listening to me on November 8th, 2018, yep, my 7th grade students, we are looking at testing next week, probably Wednesday, Thursday, probably Wednesday next week. So kind of be ready for that idea. You might want to be practicing more of these problems. Thank you for joining me when we talked about lesson 6.3. We're starting to look at those real world problems, and today we definitely challenged you to use percent proportion. Now those of you who are trying other methods, it's not wrong, it might be fine, but I am going to tell you that we're also going to look at change problems. We're also going to look at some more challenging percent problems with multiple steps, and having this percent proportion behind you could be a useful tool.